Alright, these are our notes for section 5.8 on solving radical equations. And the first thing I want to talk about is what an expression and an equation are, what the difference between the two. Now an equation, it's got part of what it is in its answer here, or in its name. It's got equa, which means it has to have an equal sign. Okay? For an expression, it's like a monomial or just a polynomial. Alright, poly. Okay? They don't have an equal sign in them. So for these over here, most of the time we're just going to be simplifying. Those are the key word that'll be in our directions for an expression. For an equation, we will see something like solve. Okay? We want to figure out what a variable equals. For an expression, we just want to reduce it as far as we possibly can. So today we're going to focus on equations. Most everything else in this chapter has been expressions and we're just simplifying them. Today though we're actually going to solve for a variable. We're going to figure out what it equals. Now to do that we've got 3 steps. The steps to solve a radical equation. First thing is to get the radical to one side, if there's only one. Okay, if there's more than one, this applies here, you get one on each side. And it depends on the type of problem you have. As we work through these today, in this video, you'll see examples of each, and then you need to make sure when you're working them out on your worksheet for your homework that you understand which process to use. If there's only one, you do one thing, a certain process. If there's 2 radicals, one on each side, you do something else. Step 2 is to cancel that radical, and you do that by raising, that sounded weird, raising each side to an exponent. And it's a specific exponent, okay? That exponent is whatever your index is. And we'll talk about that when we do the example, okay? But it has to be a specific exponent. We just don't get to pick some random one. It has to be whatever index we have in our problem. And then the last step is to check our answer, because we could get what's called an extraneous solution. Okay? And all that means is that it's an extra answer. And a lot of times those extra answers don't work. Okay, so we have to go through and check our work, plug our answer back into our problem in order to make sure it's not an extraneous solution. If it is an extraneous solution, we don't include it. Since it didn't work, it doesn't work in our problem, we don't want to give it as part of our answer. Alright, we're going to jump right in. We're going to start with examples. First one here is the square root of y minus 2, then minus 1 equals 5. Then we're going to go through our steps up here. The first thing it says is to get the radical to one side. Notice there's only one radical in this problem. It's on the left-hand side. So our goal is to get that radical by itself. In order to do that, we're going to have to add 1 to each side. Okay? That will make our problem the square root of y minus 2 equals 5 plus 1 is 6. Okay, we don't do anything with that 2 underneath, and we cannot bring that negative 1 underneath the radical because it's outside. This is outside of the radical. It doesn't work its way back underneath. Okay, we take it to the other side. Now we're at step 2 because our radical is by itself. So we're going to look at our index. Our index isn't written, so it's understood to be a 2, and we're going to raise both sides to that exponent. Okay? Since our index again was a 2, we raise both sides to the square. We're going to square both sides, and what happens is that they cancel on the side with the radical. The exponent and the index radical sign all cancel, and we're left with y minus 2 equals, and 6 squared is really 36. Now we have one more step. We got to get y by itself, so we add 2 to both sides, and y is going to equal 38. Now we've done all the work. We have to go back and check it though. We check it again to make sure that we don't have an extraneous solution, an extra answer. So you have to show this, you have to show me the check, and we're going to plug it back into the original. Square root of y minus 2 minus 1, and we want to see if that equals 5. So let's plug it in. We have 38 for y, 38 minus 2 minus 1. Well, 38 minus 2 is 36 minus 1. Square root of 36 is going to be, I'm going to rewrite it up here, 6 minus 1, and 6 minus 1 is 5, and that's what our answer should be, so it worked. Checks out. That means y minus 38 is our answer. Or, sorry, y equals 38, not y minus 38. Y equals 38 is our answer to the problem, because it worked out. Okay, let's look at the next example. Notice for this one, we've got radicals on both sides. So we solve it, we approach it a little differently. Since it's on both sides, we do need to make sure that we have the same index in the problem. Here we do. They're both the cube root. We've got the cube root of x minus 12 equals the cube root of x. Alright, we're going to take both sides to that index. So we're going to cube them both. And again, what happens is that exponent, index, and radical sign cancels. So we are left with x minus 12 equals, over here they cancel, x. Now we're solving for x, so let's take it to one side. Let's subtract x from both sides. And what happens is that we get negative 12 equals 0. Over here, this all canceled out. Negative 12 equals 0. That is a false statement. Okay, it doesn't work. And if you remember back in our other chapters, our previous chapters, if we get a false statement, that means there is no solution to this problem. Which tells us that there is no number. Okay, there isn't any number that we can plug in on both sides there that would work for both sides. Okay, and plug it in and we should get the same thing. It doesn't work. So the answer is no solution. Let's look at the third one. Third one, notice again we have the root on both sides. Now we're not going to do anything. We're not going to try to take both roots to the same side because we can't combine them. That's not going to work. We haven't learned to do that. We're just going to leave it the way that it is. We are going to look at the index though, and again our index isn't written, so it's understood to be a 2, and we're going to square both sides. The left-hand side works out nicely because they cancel each other out. Index, exponent, and the radical sign cancel, and we are left with x minus 12. On the right-hand side, something different happens. We have 2 minus the square root of x squared. Now, we've learned this before. You have to write it out next to itself, and it's actually a FOIL problem. Okay? So we have to FOIL this. The first, 2 times 2, well, that's 4. The outside, 2 times negative root x, is going to be negative 2 square root of x. The inside 2, negative root x times 2, so again, negative 2 root x. And then the last 2, negative root x times negative root x, well, that is plus the square root of x squared. The squares cancel each other out, so it's really just plus x. I'm going to rewrite that. We may run out of room for this problem. Let's write it over here. X minus 12, because that's what our left-hand side was, equals 4, combine these two in the middle, minus 2 root x minus 2 root x, well that's really minus 4 root x plus x. Okay, let's get the radical on one side by itself now, because now we only have 1. So we can subtract x from both sides. Let's also subtract 4. So our x's cancel. Negative 12 minus 4, that's negative 16, equals negative 4 squared x. Go divide both sides by negative 4. Negative 16 divided by negative 4, that is 4 equals the square root of x. Now we got to get rid of the square root, so we square both sides, because that's what our index is, and they cancel. Draw an arrow over here, because I am running out of room. I apologize for that. Okay, we get x equals, and 4 squared is really 16. So there's our answer to the problem. Now we do have to go back and check it, because we did get an answer. So let's go back. We're going to work out both sides separately here. Let's work out the left side first. It's going to be 16 minus 12. Well, 16 minus 12 is 4, and the square root of 4 is 2. So the left-hand side equals 2. Now let's work out the right. On the right-hand side, it's 2 minus the square root of 16, because that's what we got for x, which is really 2 minus 4, because the square root of 16 is 4. 2 minus 4 is negative 2. They're not equal. 2 does not equal negative 2. So this is an extraneous solution. Okay. Extraneous solution. It does not work, so we're not going to include it. Since that was the only answer we got, that means there's no solution to this problem. Okay. Again, since it was an extraneous solution, we only got one answer. There is no solution to this problem. Last one here. Okay, we've got the quantity 3y plus 1 to the 1/3 power plus 5 equals 0. Now we learned in section 5.7 about rational exponents that rational exponents are really radicals. We could rewrite it as a radical. We're not going to change it though, we're just going to leave it the way that it is. Okay? We're going to treat it though as if it were a radical, so we have to get it to one side by itself. So let's minus 5, and we have 3y plus 1 to the 1/3 equals negative 5. Now we're going to raise both sides to a power, and that power is whatever our denominator is, because remember, if we rewrite it, the denominator becomes the index if we were to rewrite it as a radical. So since our denominator is 3, we're going to cube both sides. And what happens is that those cancel out. The 1/3 times 3, it's really 1. Anything to the first power is itself. So that left-hand side now is really 3y plus 1 equals, and negative 5 to the 3rd power is negative 125. We are going to subtract 1, so 3y equals negative 126. Divide both sides by 3. Y is going to equal a negative 42. Now we have to check it. We got an answer, so we have to check. We're going to go back to the original. Since everything's on the left-hand side, we're just going to plug it into the left-hand side and see if we get 0. So now it's 3 times negative 42 plus 1 to the 1/3 power plus 5. We want to make sure that equals 0. Well, 3 times negative 42, that's really negative 126 plus 1 to the 1/3 power plus 5. Negative 126 plus 1, that's negative 125 to the 1/3 power plus 5. Negative 125 to the 1/3, that's negative 5. Okay, it's really the cube root of a negative 125. We could rewrite it if we need to. We could look on our chart to find that. It's negative 5. So we have negative 5 plus 5, which is 0, which is what we want. So it works out, which means y equals negative 42 is our answer to the problem. Okay, those are our notes for section 5.8 on solving radical equations. One thing I do want you to remember is that you have to pay attention to that index. Okay, that tells you what side or what exponent you have to raise both sides to, and then you have to check your answer. Okay, to check and see if it's an extraneous solution. By far, I think this example, our third example, was the hardest. And again, I didn't leave us enough room to work it out, so it's kind of messy. But that is the hardest type. Everything else should be pretty straightforward, but that third example is the most difficult. So make sure you understand that one, because I think that's where we'll have the most problems. Alright, again, those are your notes for 5.8, solving radical equations.